Recently, Richard from the Learn Electronics Repair channel set a challenge of designing the smallest possible signal injector. This is for audio signal injection. I think the criteria was for it to be a square wave. There was no criteria for frequency, and the design brief was to make it as small as possible. So in today's video I'm going to go over a design for such a device, and I'll explain the reason why I've chosen certain things in this design and why I haven't actually uploaded this to PCBWay.com. If you'd like to see an audio signal injector, then this is the video for you. Let's go.
I put together one of these. Okay, one of these. This is the surface mount one built. So just for now, I've just attached this to my bench power supply, but the plan would be that the whole thing, including the battery, fits into the pen. Okay, I'll just show you that this one actually does work. So here is my injector. The power supply is set to 1.5 volts, which is what this will run on. Okay, it has a little on-off switch. Okay, I'll just get the connection to my speakers. You hear that? Doesn't have to be a big size biro, but you know, something like this. That was like a Sharpie type pen. Yeah. As long as it'll fit into something like that, I think that will pass the test. Yeah. So let's keep this interactive, guys.
This is the prototype device that I came up with. The reason I've done it this way, firstly, the design brief was to make it as small as possible, and yet it had to fit inside of like a Sharpie type pen. To me, those two things don't add up, because if you've got to fit inside the Sharpie pen, then the size of the design, as long as it fits inside a Sharpie pen, should be good. I've actually designed mine with specific goals in mind, and that is based around functionality as well as size. Previously, I have actually built one of these many years ago, and at that time I did do some experiments with different supply voltages, whether it should be battery powered or powered from the circuit that you're actually using. Now, in my experience, it's actually much better to power something like this from the circuit that you're actually testing. Then you get a good ground reference. There's not a huge amount of noise induced, but that wasn't the design brief. So I have come up with this design based on a 555 timer of all things. Now, the reason I've chosen that is because it's a low component count. I've actually got 5 components on my PCB plus the switch and the battery. Secondly, this particular package is extremely small and is ideal for the size requirements. In addition to that, it operates over a very wide operating voltage from somewhere around 4 volts to around 18 to 20 volts. That way you have a good selection of batteries that you can actually use. I'll show you a couple of batteries that I've actually selected to power this device, but it can equally be powered from a, say for example, a 15 volt supply from a circuit that you're working on. So with all that said, I haven't deliberately made this as small as it can possibly be. I've actually sized the PCB to fit to the batteries that I've selected to power it from, and therefore it is a little bit bigger, but it still should fit quite easily inside of the type of pen that was mentioned on the design brief. So with all that said, I'm not going to upload the design onto PCBWay, but I'm just going to show this video just to show what I have come up with. So let's go. So the device I have actually measures 25 millimeters by 12 millimeters, and I'll just demonstrate running on 2 different battery voltages here. So I've got 2 lithium batteries in parallel here, so it's about 3.74 volts ish. So if we just connect that one first, and connect the output, we'll be able to hear. So that's the output at 3.7 volts. And then I'll do the same, and I'll just literally connect this up to the two in series, so we're going to have about 8 volts here approximately. We can see it's considerably louder and the frequency is slightly different too. And this is literally just the output connected, so there's no ground connected, which is exactly what you want in this kind of probe. So obviously there's a lot of noise induced because there's no ground connection, but the device is still working pretty well. I have also got a very small tactile switch here mounted to a small PCB, and I'll also put a spring connection onto that so I can connect to this via battery. And I'm just going to literally going to attach this onto here, and then I can have an on-off switch. As I said in the intro to the video, I've made one of these in the past, and what I found in the past was if you power these from a very low voltage power supply, and the fact that you're not actually using a grounded connection for the signal injection, you need to actually have decent voltage coming out of the thing for this to work well. So with that in mind, I've actually opted, rather than a low voltage 1.5 to 3 volts battery supply, I've decided to go for a much higher voltage. And with that in mind, I've got two options with my PCB. I've got these guys, which are LIR 425. These are rechargeable lithium batteries that are used in fishing floats, etc. So I was going to put two of those in series to give me around 8 volts. Or the other option, and as you see, these are actually pretty much the same size, physical size. The other option is to use a 12 volt alkaline number 23 alkaline battery. These are 12 volt. So as I said, these are actually rechargeable. The charger actually looks like this. It's just a USB charger, and you literally take the batteries and insert them into the charger, and they can be recharged. You can do 2 or 4 at a time with this guy. So, and in addition to that, I'd made a simple battery holder for this device just out of some perspex, and what there is there's actually a piece of nickel inside of here, so I can insert the two batteries. So I can insert one this way, so it's touching the piece of nickel inside, and then one this way to make the short circuit in there. Then I have plus and minus here, and I literally just made a little top cover to go on there like that, and then that enables me then to have a cell which is the same physical size as the 12 volt cell. This is obviously 8 volts, this is 12 volts, but that enables me to have options with my PCB, because the design of the PCB will enable me to use either or of these batteries. So I have made a mock-up of the circuit. This is actually slightly larger than the PCB that I've actually designed, but I just had made this out of some parts that I had kicking around. So you can see it's basically a 555 timer, some capacitors, a couple of resistors, and a switch, and the power source, which can be either that or one of those. So if I connect this up to the oscilloscope, and this is totally ungrounded at the moment, and then we can look at the waveform coming out of the thing. Just need to connect my battery up a little bit better. Okay, so we can see that we've got about 230 millivolts peak to peak, and a frequency of just under 3 kilohertz. And what I'll do now is I will just connect the ground up on the scope so you can actually see the difference. So let's just try and connect the ground. Not quite so easy. Okay, ground's connected. And we can see now that we've got about 680 millivolts with the ground connected. And to hear what that sounds like, I've just got a small speaker connected up here. So again, ungrounded, I'll just connect the output, which is this yellow wire, and you can hear the output from the speaker. So it's a quite decent strong signal. The schematic itself looks something like this. So it's literally a 555. We've got a 1K and a 3K9 resistor. Now I chose 3K9 to give me an output frequency of around 3 kHz. You can actually change the output frequency to what you want. You could actually put a potentiometer in place of this resistor to have it adjustable from probably around 50 Hz to around 5K, maybe somewhere around there. And of course you can change the capacitors as well. But I think this is fine. 3K, 3 kHz signal is ideal for this kind of work. It's nice high frequency, so you can actually hear it very well. It's quite piercing. So I think this is, for me, this is a good frequency to choose. So here's the layout of the PCB. The dimensions are going to be 10mm by 30mm, which will enable me to put some spring contacts in so I can mount the battery nicely on the underneath. The batteries themselves, the alkaline battery is actually approximately 10mm in diameter. So with the thickness of the board and the components, it may be that the overall diameter with one of those batteries will be a little bit bigger than will fit in the pen. Not entirely sure, but the battery that I've designed with the 2 lithium batteries is exactly 10mm by 5mm, so that will fit in very nicely inside probably a 10mm diameter pen. And then in 3D view, this is the top part of the PCB. Clearly I've got a vertically mounted pin header on here. That's obviously going to make the board quite a lot taller than it really needs to be. It's easy just not to put that on and solder directly to the terminal pads, or I could put a 90-degree header on there. That's just there for representation. And then the back side of the PCB looks like this. So I've got 2 pads here, which can either be positive or negative, depending on the configuration of battery that you want to use. So I've got the 2 spaced apart here, which are the spacing if you're going to use the lithium battery, or you can connect a single pad and a spring up to here for one terminal when using the alkaline battery, and another spring on this end for the opposite terminal. It's fully configurable to use either type of battery that you choose to use.